Hi everyone, today we'll be learning a very important topic in calculus, and it's the limits of a function. So this one is a very fundamental concept in calculus because the other concepts in calculus are related to it. So first, let's define what a limit is. So a limit is a certain value that a function approaches as the function's inputs get closer and closer to a certain number. So for the example that we have here, if we have the limit of f of x as x approaches 3 equal to 8, then that means that if x gets closer to 3, then f of x gets closer to 8. So the properties of the limits are also very dependent on its neighborhood. So the limit of a function fail to exist at a given point when we look at the neighborhood of that point. What does that mean? So that means that if from the left side and from the right side the functions are equal, the limits of the functions are equal and they approach that same value, then that means our limit exists. But if the left side limit and the right side limit are not equal to each other, then that means that the limit at that certain point C does not exist. So there are various ways on how to compute the limit of a function, but specifically today we'll be talking about using direct substitution, factoring or manipulation of the equation, and rationalizing by using the conjugate. So first, let's start with the easiest part of determining the limits of a function, which is by direct substitution. So if we have this equation right here, the limit of negative 3x cubed minus 7x plus 8 as x approaches 0, what we can do here is just replace x with 0 to get the limit. So that will be negative 3, 0 cubed minus 7 times 0 plus 8, or 8. So that means the limit of this function as x approaches 0 is 8. We also call these methods determining the limit algebraically because we're looking for the limits using algebra, because there are other methods like graphical and such. So this one is the second example. So if we want to find the limit of square root of 51 minus 2x as x approaches 1, then we just directly substitute x to 1 to x, so that will be the square root of 49 or 7. So the limit of this function as x approaches 1 is 7. So the direct substitution does not happen all the time, so that means we have to learn other methods on how to find the limit. So if we have this one, for example, the limit as x approaches 3 of x minus 5 squared over x minus 3 squared, then that will be 3 minus 5 squared at the numerator and 3 minus 3 squared at the denominator. So if you notice that we have a denominator here which is equal to 0, and that is an undefined number. So we can't really manipulate anything right here, so that means at this point the limit does not exist. Okay, here's another example that we can work on. So that's the limit as x approaches negative 2 of x cubed plus 3x squared plus 2x all over x plus 2. So notice that we can factor the numerator that we have here. So if we directly substitute negative 2 here, we will get a 0 value for the denominator. So we're doing this factoring so that we can try to manipulate the equation and get a value. So if we factor the numerator, we can get x plus 1, and x plus 2 as its factors, and the denominator x plus 2. So here we can cancel x plus 2 and we were given x plus 1 as the limit. And we just plug in negative 2 here, so that will be negative 2 times negative 1, and that gives us 2. So the limit of this function as x approaches negative 2 is 2. Let's try another example where we use factoring. So let's try limit as x approaches 2 of x cubed minus 2x squared all over x squared minus 4. So if we directly substitute 2 here, then we will get 2 cubed minus 2 times 2 squared all over 2 squared minus 4. And if we try to solve for that one, that will give us a 0 over 0. So what we can do is manipulate the equation that we have, so we have to try factoring. So for the numerator, we can see that we have a common monomial factor, which is x squared. So we have to factor out x squared on the numerator. And that leaves us with x minus 2 inside the parenthesis over the factors of x squared minus 4, which is the difference of 2 squares. So that will be x plus 2 and x minus 2. Here we can cancel x minus 2, so that leaves us with x squared over x plus 2. And if we directly substitute 2 there, we will get 4 over 4, or 1. So that means that the limit of this function as x approaches 2 is 1. Okay, so let's try another example. Let's try the limit as x approaches 3 of x minus 3 over square root of 4x plus 4 minus 4. So when we see something like this, the first thing is that we have to substitute by the given value. And if we try to do that, this will give us an output which is equal to 0 over 0, and that is not possible because that's undefined. So what we can do here is try rationalizing using the conjugate. So let's just multiply this whole equation by the conjugate of our denominator. So the conjugate of our denominator, we just have to change the sign in between the square root and the number. So that will be 4x plus 4. The square root of 4x plus 4 plus 4. We're doing it for the numerator and for the denominator, so it's just like we're multiplying this whole thing to 1. So for the numerator, that will be x minus 3 times square root of 4x plus 4 plus 4 all over the square root of 4x plus 4 times itself will be 4x plus 4 minus 4 times 4, and that's 16. So the numerator stays, and it's x minus 3 times the square root of 4x plus 4 plus 4 all over 4x plus 4 minus 16 is negative 12. If we look at the denominator, we can factor out a common monomial factor, which is 4. So after we rewrite the numerator, since we did not change anything there, we can factor out 4 on the denominator, and that leaves us with 4 times x minus 3. Here we can cancel x minus 3. So that will just be the square root of 4x plus 4 plus 4 all over 4. Now we can try substituting 3 to get a value for the limit. So that's 4 times 3 plus 4 plus 4 over 4. Okay, so that will be the square root of 16, or 4, plus 4 over 4, or 4 plus 4 over 4, which is 8 over 4, or 2. So the limit of this function as x approaches 3 is. So let's try this next example, which is the limit as x approaches negative 1 of x plus 1 all over x plus 5 minus 2. Here, if we directly substitute negative 1, we will again get 0 over 0, and that is undefined. So that means we can try manipulating this equation algebraically by rationalizing it using the conjugate. So the conjugate of the square root of x plus 5 minus 2, as we talked about earlier, would just be the same thing except the sign in the middle will be replaced with the opposite sign. So that will be x plus 1 all over a square root of x plus 5 minus 2 multiplied to the square root of x plus 5 plus 2 all over the square root of x plus 5 plus 2. So that is just all equal to 1, so that's just multiplying it to 1. Now let's multiply. So for the numerator, we can retain it that way. X plus 1 times square root of x plus 5 plus 2 all over x plus 5 minus 4. Now if we look at the denominator here, we can combine the similar terms, which are 5 and negative 4. So on the denominator, that leaves us with x plus 1. So we can now cancel x plus 1, and that leaves us with the square root of x plus 5 plus 2. Now if we substitute negative 1 in this equation, we'll get square root of negative 1 plus 5 plus 2, or the square root of 4 plus 2, and that will just be 2 plus 2, or 4. So the limit of this function as x approaches negative 1 is 4.